Hi, my name is Kelly Aitken. I'm the Business Development Officer for the Digit Me Too project, which is a European Regional Development funded project based at the University of Central Lancashire's Burnley campus. We provide up to 150 hours of fully funded support to help Lancashire-based manufacturing SMEs adopt Industry 4.0. Our team specialises in data visualisation, data analytics, IIoT, the Industrial Internet of Things, as well as robotics and automation. This video is part of a series of videos designed to give you a more detailed insight into each of these subjects. Please contact me using the details on the screen to discuss how Digit Me Too can help your company. Thank you for listening.
Hi, and welcome to this video on IIoT. This is the second video on the Industrial Internet of Things, so if you've not seen the first one yet, you might want to go and watch that now. It's on our Digit Me Too channel. In this video, I'm going to show you how to set up a small IoT style device based on a Raspberry Pi that communicates with a data broker, and then how to get those readings onto a simple dashboard. I'll start with the hardware setup for the Raspberry Pi. This is the electronics for the sensors. I'm using an AM2302 digital temperature and humidity sensor, an LED to indicate an output, and a simple switch. The circuit's built on a breadboard for simplicity, but if you wanted to actually put this up on a wall somewhere, you'd probably be better soldering it together. If you don't have a circuit board, a strip board will do the job. I'm using the 3.3 volts and ground output lines on the Pi to power the sensors, since they don't use too much power and it's an easy way of doing it. The Pi itself is powered from a USB power supply. All the connections between the Pi and the sensors are made with jumper wires, which just look like this. Simple, plug straight in. The AM2302 data line, this yellow wire, is connected to GPIO pin 4 on the Pi, and then the LED and the switch are connected to GPIO pin 17 and 27 respectively. We need to know this so that we know which pins to point the script at. If you're following along and building your own circuitry at this point, feel free to hit pause, do that, and come back when you're ready. The next step is to set up the software for the Pi. Pi is running on Raspberry Pi OS Buster. There are instructions available for how to set this up on the Raspberry Pi website, including a download link and a guide to get the image onto an SD card. If you need to do that, hit pause now and come back when you've got your Raspberry Pi set up and running. Next, the libraries that I'm using to talk to the Pi GPIO need to be installed. I'm using the Adafruit Blinker CircuitPython libraries, which can handle both the digital I/O that drives the LED and the switch, and also talking to the AM2302. The pages for this are linked in the description. Your Raspberry Pi needs to be online for this, so connected to either Wi-Fi or Ethernet and able to access the internet. So open a terminal on the Pi, it's a little black box icon in the bar at the top, and start by doing an apt-get update followed by an apt-get upgrade. This brings the current software on the Pi up to date. It might take a while to do this. Then install Python pip3 and the Python setup tools. pip3 is Python 3's package management tool, and we'll use it to install the rest of the Adafruit CircuitPython libraries. Next is our pi.gpio. Now you might find that a number of these libraries are already installed. In that case, it doesn't matter, the system will just skip that package. I use the Adafruit CircuitPython libraries to talk to the GPIO pins on the Pi. This is the bit that handles talking to the AM2302 sensor. The last package that needs to be installed is the MQTT client library from the Eclipse Paho MQTT page. It's worth mentioning that you could also run Mosquito on the Pi if you wanted to. You might find it easier than putting out a different machine if you're following along. On either Raspberry Pi OS or Ubuntu, Mosquito can be installed by running the command apt-get install Mosquito. Note that it's spelled with 2 T's. Okay, so now that all the supporting libraries are installed, we can get onto the Python script that turns the Pi into an IoT device. The full code that runs on the Pi is available on our GitHub page, which will be linked in the description, and is called IoT device script.py. There are 3 particularly important parts I'd like to point out. The address of the data broker is set on line 17, which needs to be set to wherever Mosquito is running. Ideally, this should be a static IP address if it's a machine on your local network, or the address of the cloud server you're using if you're making use of one provided by a company. The callback function on message that starts on line 39 and ends on line 47 runs whenever the script receives a message from the data broker. The only subscription that this script makes on line 31 is to the topic that carries command to turn the LED on or off. The while loop in main, starting on line 61, is where the program spends the majority of its time. This reads temperature and humidity periodically and publishes the readings if the Pi manages to read the sensor. I say if because of the way this sensor works. They use a type of one-wire interface where the binary ones and zeros are represented by different durations of pulses. Offhand I think it's between 10 and 50 microseconds. Raspberry Pi OS is a multitasking operating system, which means that while it appears to be doing everything at the same time, it isn't actually, and what it's doing is it splits its time between different tasks. The sensor doesn't allow for this, so it's entirely possible for the Pi to start reading the sensor, switch to a different task and miss the end of the message, and so fail to actually get any readings. The library that I'm using works reasonably reliably on a Pi 3. I have tried it on a Raspberry Pi Zero as well, but it didn't really work, so it looks like it only works on the faster models. For this demo, the temperature and humidity is read about every 5 seconds. This can be changed on line 18, and if you want to run this for any length of time, you probably want to set this to maybe 10 or 20 minutes. Copy the script to the Pi and run it from the terminal. You can either change the permissions of the file to make it executable, or simply call the Python 3 interpreter and give it the path to the file. If everything works, you should start to see the readings being printed to the terminal. This does assume that the script has managed to correctly connect to the data broker, as if it can't, I expect it will hang at the start of the script. The other half of the system that needs to be set up is the dashboard. It's built in Node-RED and uses some additional packages to produce a nice dashboard that can be viewed in the browser. Links for the various packages will be in the description. The entire Node-RED flow is available as a JSON file that can be imported. It's on our GitHub page. The blue button on the Initialize Database node can be clicked once the flow is deployed and will set up a database. This ended up with these 6 nodes because I couldn't seem to find a way to get a single SQLite node to execute more than one statement. This works for a small system like this, but if it got any bigger you'd probably want to look at other ways for setting up the database. If you're running this on your machine, you'll need to change the server address for the MQTT data broker for each MQTT node, and the path that the database will be at. Other than that, as long as you have the relevant nodes installed, everything should work. To update the address that the MQTT data broker points at, double-click on one of the MQTT nodes and then click on the pencil, and then adjust localhost to either the address of a machine on your network where the data broker is running, typically a static IP address, or to the address given by your cloud provider. Click update and done, and then that's updated. To do the same for the database, double click on one of the SQLite nodes, again click the pencil, and then change this path to where you want the database to be saved. Click update, click done, and that should be everything that needs to be changed. Click on deploy, and then if this is the first time running this flow, click the inject button here to start the process of initializing the database. Once that's done, click this button to open the user interface page. This graph shows readings collected over the last 24 hours by default, and the 2 gauges are the latest readings. You can turn the LED on and off with these buttons, which make Node-RED publish on and off to the LED command topic. So that just about wraps up this video. If you've any questions or if you'd like to work with DigitMeter on a project, feel free to get in touch with us. The contact details will be on the screen in a moment. Thanks for watching.